everyone. So I'm here to start with my topic on software engineering, and my name is Vartika Jain and I'm working in RKJIT Ghaziabad as an assistant professor in CSC department. So my topic is software engineering and I'm going to start with introduction of software engineering. So these are the various contents which you are going to cover in today's lecture. Introduction to software engineering, software components, characteristics of software, software engineering processes, similarities and differences from conventional engineering, software quality attributes, software development lifecycle, SDLC, waterfall model and spiral model. So starting with software engineering. So what is basically software engineering? Software engineering is a systematic and disciplined approach to get any development of the software product. So basically the phases which involve in during the development of any software are requirements gathering and analysis of the requirement, designing, implementation and development of the codes, and after that testing and deployment of the software at the client side and its maintenance. So these are the phases that are involved in the development of software engineering process. So these are the various components, components which are used in softwares. First is code that performs a specific task during the software development or software processing. And second one is data, the information on which any of the programs operate. Third one is documentation. It involves all the manuals, guidelines and any type of technical guides to for the users and the developers. Fourth one is operating procedures. It involves all the instructions for the running and maintenance of the software. Next, these are the various characteristics of the software. First one is intangibility. Intangibility is related to that software is not physical approach. It's a like we can't touch it, we can't feel it, but it is like we can use it. Second one is flexibility, like if we can modify, we can change any of the changes which is required according to our users need in this. Durability, it do not wear out like hardware, we can upgrade it according to our needs, according to the market requirements. Fourth one is its complexity. These are not complex, it's like large and integrate systems, like we can manage the complexity in this. Fifth one is reusability, that are software components and codes that can be reused in further development of any other softwares. Sixth one is maintainability, that means it can be adapted, upgraded and can be corrected for the further use. Next, we are going to start with the software engineering processes. These are the various processes that are involved during the development of any software products. Like first one is requirement analysis. Requirement analysis is the gathering and analysis of the requirements that we gather from requirements, the needs of the customers or stakeholders, and we gather the data from the market, from any of the places, and then we analyze the data according to our needs. And second one is system designing. Designing is the part of planning is the part of designing, like we plan out the things, how we process further with the development part, and we design user manuals and guidelines, like how we will we go ahead with the development of the software products. Third one is implementation. It includes all the codings and all the source code, objects codes, all involved in the implementation part. Our development part is the main part of the software engineering processes, because we get the final output in this implementation part. The final output is then tested in the testing, like we fix the bugs, we check the bugs whether it is running properly or there is no errors in between the software products. Then we are going to deployment part. Deployment is the we get the final software product, then we deploy at the client side, at our stakeholder side, so that we can train them accordingly to use the products. These are mainly the main work of the deployment. Then once we deploy our product at the client side, then maintenance. What is the part of maintenance? Maintenance if any of the problem, if our client need any kind of modification or any kind of changes in according to his needs, so then we can maintain, we can upgrade our software products according to that need, and we can, meanwhile, if any of the bugs generate during the use of stakeholders, then we can fix that bugs in the maintenance part only. So these are the basic software engineering processes which involve, and these are similarities between and differences from the conventional engineering. Conventional engineering or traditional engineering is the engineering that we are using for any kind of physical product like bridges, machines, any kind of like physical products we are using conventional engineering. So what are the similarities between software engineering and conventional engineering? These are the similarities, like use of structured methods and tools. In both of the things, both of the software engineering and conventional engineering, we are using a structured method and a proper tools for the to generate any kind of products. Second one is project planning and documentation. For any kind of product development, we need a proper documentation, and before that we require a planning, how we are going to develop the things and how we are going moving ahead. So third similarity is testing and validation. Again, we get our output, we get our product, then we will do testing and validating by whether our product is working good, it is reliable, is it easy to use or efficient or not. Fourth one is focus on quality and reliability. Again, it both focus on high quality products and reliability, whether they are secure or not, whether they are reliable or not. These are the similarities between both the engineering. Now the differences is like software is intangible, as we discussed. We can't feel it, that is not physical. We can use it, but we can't feel it, we can't see them in the physical mode. So easily changeable, we can modify them, but in conventional engineering, that are physical mode and we can't change, we can't modify any kind of products. Second one is fewer constraints from physical materials. There are fewer constraints which we feel in software engineering, but not in conventional engineering. Third one is maintenance is more frequent and flexible. Like maintenance part is more easier, more flexible in software engineering as compared to conventional engineering. These are more flexible and we can do our modification more frequently as compared to conventional engineering. So these are the basic similarities and differences between both the engineering. Now we are coming to the quality attributes, software quality attributes. So these are the basic software quality attributes which we are having in our softwares. First is its functionality, second one is reliability, third one is usability, fourth one is efficiency, then maintainability, portability, and security. So starting with functionality. Functionality, we are focusing on correctness. It's going to be accurate, it's going to be correct and suitable, whatever we are suitable to our customers' needs basically. So functionality is the one of the major attribute of any kind of software product. Second one is reliability. It should be consistent in over the time while we are like using it. It should be consistent in performance. So second one, our reliability, it should be reliable to our stakeholders. Third one is usability. It should be user friendly. It should be its UI should be user friendly. Like if our customer is naive to use, he is new to use the our product, so it will be that much friendly that he can easily adapt to the new things, new software. Fourth one is efficiency. Like resource utilization is the must part to go ahead with the sustainability these days. So it should be efficient as in the sense of CPU and memory. And maintainability, easy to make the changes. Like if we want to make any kind of changes, we want to upgrade the changes, if we want to make changes according to our customers' need, so it should be easy to maintain. Then it is one of the property of maintainability, is the one of the property of quality attributes. Then next is portability. Like it should run on any kind of OS or any kind of operating system, it should be portable to use. Like if we want to run it in Linux, or whether we want to run it in on Windows, so it should be portable and easy to use, or easy to like install in any kind of operating system. Next is security. It should be uh, highly secure. Like if any kind of malware, any kind of like virus is there, so it should be authorized access. There should be authorized access to that particular software. So it should be secure, highly secure to any kind of unauthorized access. These are the various attributes. Now we are going ahead with software development life cycle. That is our SDLC. So what exactly the SDLC? SDLC is the structured process of development of any software through the well-defined phases. These are the SDLC, and we have multiple models to define our software development life cycles. So basically the main role of SDLC is to get high quality software products that is efficient, cost efficient, within the budget, and deliver within the given time, and output the quality of the product should be high quality, and output we are getting should be free from any kind of errors and highly secure. Different models offer different kind of approaches. There are multiple models we are studying, like but there are various models, like we are having waterfall model, spiral model, agile model, and iterative model, prototype model. All of the models have different approach. All of the models have different pros and cons in terms of we go ahead with the project developments. So all of them have different kind of pros and cons. So we are going to study today waterfall approach, waterfall model. So starting with waterfall model, it follows the linear approach. It follows the linear sequential approach to follow any kind of product development. So first, in the first phase, we are having requirement gathering and analysis. We will gather the requirement from the client side, from the stakeholders, from our customers. As per their requirement, we will process ahead with gathering of the requirement, gathering of the data, and we will analyze whether it is whatever it is the useful. We will include with our data with our requirement, and we will document it in designing part. We will document the things, we will develop the SRS, we will plan out the things and design the proper goals, how we are going ahead, and we will design the front end of the our project in designing part. Now third one is implementation. Implementation is the development any kind of software, like we are doing instructions, we are developing our codes in the implementation. Now after the development of our model, then next phase is our testing phase. Testing phase is we are seeking for the bugs, there is no bugs should be there, no there is no any kind of gaps, consistency should be there. So we are checking that part in the testing, and once the testing is done, once we fix the bugs, then we will move ahead with the deployment part. Deployment part is again we are deploying our final product to our client side so that he can adapt the things. In this deployment, we are also providing training to the customers, to our clients, so that they can easily use the things. So after deployment, we will release it and starting doing maintenance. Once we are deploying the things, we will get multiple kind of ticket trace from the client side. They can get any kind of big bugs or any kind of problems or any kind of things, like if they are like looking for these changes can be added, these updation should be added, that all should be done in maintenance part. So these are the simple phases which are included in waterfall model, which is linear sequential model. After the completion of the one phase, then only we will start with another phase. So if we go ahead with that, it is simple to use, it is easy to manage, but clear documentation is also there, but it is rigid and inflexible at the same time. So it is inflexible because we can't update during our development. Once the development is done, then we can update the things. Also, clear documentation and milestones is its advantages. At the same time, it is not suitable for complex or any kind of involving requirements. Like if we are having any kind of complex or big requirements, then we can't go ahead with waterfall model. Although it is comparatively less expensive, but we can't go with complex models, big models. We can only like go ahead with agile or spiral for the kind of models. We can't go ahead with that. Later discovery of errors. We can later discover our errors in this. Once our maintenance and our deployment is done, then only we will get to know our errors, and then we can fix it on our maintenance part. Now, spiral model. Spiral, as its name, it's go in the shape of a spiral. Like first our step is planning, then risk analysis, then engineering, and then evaluation. Planning is in the first cycle. Like planning, we will gather the requirements, like we earlier we done in waterfall model. In this also, we are gathering the requirements, and then requirement analysis is done. After requirement analysis is done, we will plan out the things, how we will move ahead with these things, with our requirements. Now, after planning, we will go ahead with risk analysis. This is the major thing with this, that is a pro of like spiral model. Like in between, we can predict our risk at the same time. Like we can predict our risk, what kind of risk can be further, it can be move, like what kind of risk can be there. We can predict in the risk analysis, and risk can be managed in this risk analysis. We can analyze the risk and we can manage the risk at the same time in the second level of spiral model. Third is engineering. Engineering is again the part of like designing, coding, and testing. We will do our designing part, our testing part, and also our implementation part in engineering. Now, after engineering, next is evaluation. Evaluation is based on the customer's evaluation, customer's feedback analysis. We will get the feedback from our customer, then we will go ahead with like what kind of evaluation, what kind of changes is required in this. So this spiral model is basically based on risk analysis and customer evaluation. That is a pro of this particular model. It is more reliable, it is managing the risk at the same time, and it is totally customer friendly. Like if our customer require any kind of any kind of changes, so we can do at the same time, and why we will release the like final product like when our customer is fully satisfied in the last phase of the model. So now, so these are the basic advantages and disadvantages of a spiral model. Like risk management at every stage. As I told you, risk analysis, risk management is quite important part, and it is a very positive pro for spiral model, and it is flexible to changes. If any kind of changes we require during the development of the product, then we can do in between. We can go ahead for large and complex models. This is very good for large and complex models, but at the same time, it is very complex to manage, and also it is quite expensive, as we are going ahead according to our customers' feedback again and again. So we are processing all the rounds again and again, so it is going to be a bit expensive. So also it requires expert risk assessment. Like we require a particular candidate to check the to manage to predict the risk at the same time, and manage the risk at the same time, to take care of the risk analysis and risk management part. So that's it for today. Thank you.